This is our presentation over desalination plants. We are at Metropolitan Community College, Blue River campus. The contributors are Shelby Huber, Colin Lee, and Anna Zinnerman. What is a desalination plant? A desalination plant is a water treatment facility that converts salt water into fresh water. It gives us access to water found in the ocean which we previously were unable to use. Why are desalination plants worth talking about? This is definitely worth talking about since it's a newer technology that serves as an alternative solution to traditional water plants, with the form of reverse osmosis being invented in 1965 by Alexander Sarthman. And it has the potential to help countries that are in a water crisis. And what this presentation will cover. Throughout this presentation, we'll cover the current ways of obtaining drinking water, how do water desalination plants work, the various advantages and disadvantages of using water desalination plants, what parts and countries of the world are currently implementing water desalination plants, and some potential alternative solutions to desalination plants. 1.
Hello, I'm Shelby Huber, and I'm going to kind of go over the state of water right now, how we use it, and how desalination plants work. All right, Earth's water resources. If you haven't known, we're kind of running out of drinkable water now. This is an illustration of when fresh water meets salt water. They clash. It's no good. So this diagram kind of shows how water is used, like how it's stored naturally. So this is all the water in the world. See, it's all this. The blue is the oceans, and this little bitty sliver is fresh water. And fresh water is what we drink. We do not drink salt water. So from this sliver, 3% of the Earth's water goes down here to fresh water. Now, the fresh water is kind of divided into 3 categories, such as how it's stored naturally on Earth. So this is the ice caps and glaciers. This is the groundwater. And this is easily accessible surface water, such as lakes and rivers, any fluvial streams. So from that 3%, 79% is held in ice caps. And we can't drink ice caps because it's solid. We need liquid. We drink liquid water. So from that 21% is what we can access. And we usually use, in the United States anyway, but I'll get more to that. The United States usually uses groundwater, but a lot of other places will usually use more fluvial system, and that's 1%. So as you go down, like I spoke before, that 1% is made of lakes, rivers, soil moisture, which is a little bit different than groundwater, and atmospheric water vapor. All right, how do we get our drinking water? Okay, first we need precipitation. It has to fall from the sky, and it's rain. So we have rain, snow, and melting ice caps, which is happening a lot more rapidly now than ever before. Freshwater deposits such as lakes, rivers, and groundwater. Like I said before, the United States mostly uses groundwater, but the problem with that is that out of all the freshwater deposits listed above, the U.S. uses 90% of aquifers to disperse drinking water, which is, they're non-renewable sources of water supply. Like we're basically what that's saying is we're going to run out. All right, how do we get our drinking water? How does the water from the sky, rain to lakes get to our sinks? So from this diagram, we see obviously the cloud represents the rain, and then this little portion represents how we need a large surface level system of water. So from a collection of natural freshwater deposits, the water we use every day is stored in a public water supply system. This is the public water supply system. First it goes through a water tower, sewer lines, septic systems, wastewater plants, and then finally discharge. So from precipitation to the water deposit above, it goes into a water tower, which I for a long time I had no idea what these were actually used for, but what they're used for is that they store water in these large towers, and they create pressure, and the pressure results in the distribution of the water going down from the water tower creates pressure filtering out to our sinks and our whatever we use our water for. Such like that. So obviously you can see from the water tower we go to our homes, and as we use that water it goes down to the sewer lines, the septic systems, which is waste, biological waste, meaning feces and such. So after that we go to wastewater plants, where a lot of that is kind of filtered out from just biological matter and just waste. And then finally it's discharged, and this picture shows that lovely discharge. All right, so desalination plants, how do they work? What do they do that's different from what we've been doing with the drinking water cycle? All right, first you need a saltwater location. So that means obviously the ocean. That's where we get our salt water. We need to pre-treat the brackish and impure salt water. We need to use reverse osmosis in these technologies. We need to separate the fresh water from the salt water after reverse osmosis is done, and allow purifying solutes by adding minerals suitable for drinking. All right, in this picture above, this is showing a desalination plant in California. Right here, this is this little guy right here. He is the creator of Ed Carbon, a desalination plant company that is working to kind of find different solutions of drinking water, to get different ways of distributing drinking water. So in the United States, obviously you're going to get these desalination plant locations in the east and west oceanic coasts. The major companies such as Ed Carbon are also Captura and Physical Sciences Incorporated in the United States. The prime locations right now for desalination plants are Florida, California, and Texas. All right. The big component of desalination plants are reverse osmosis. Now, osmosis is basically a filtration system that works with turning concentrated solutions into a water solvent type of solution, I guess I should say. Okay, so regular osmosis works with the concentrated solution into a filtrated permeable membrane, and then it turns into, it removes all the ions basically in the solution. So in the reverse osmosis is basically like a filter using external pressure, such as the salt water, removing the ions, turning it into fresh water. All right, so after reverse osmosis happens, we need to basically treat the water that we have obtained after removing all the all the salt ions and everything from the salt water. So after you remove salt water from, the salt from the water, you're going to get brine. And something to think about, brine is kind of what we use to denature a lot of things like enzymes. And we use this a lot with cooking, such as like, cooking with our meat, and this is what we get from, that's the byproduct of how we're cooking. So this is in the ocean, which, to emphasize more, we don't want to drink it. So we have to put some depurifying solutes into the water, like safe chemicals and minerals. A safe chemical such as chlorine to get rid of any bacteria and dirt at a safe concentration. And then we're also going to get some carbon to kind of like, I guess, make it a little less dense is what we basically want from that. And then some minerals such as fluoride and calcium. The fluoride, a lot of cities and towns want fluoride, so that will help the enamel in our teeth. Basically, these minerals just kind of help us profit from, to profit our bodies from consuming such things like this. So we have fluoride and we also have calcium to help our bones. Next slide. All right, so pre-treated water filtration. It needs to remove tiny micro whatevers. So we're gonna remove sediments, biological matter, and waste matter. So what I mean by that, sediments are like sand and mud. Anything, any geological small particles we need to get out of the water. And then we have biological matter living in the water after we've taken it out. And that means any plantation, microorganisms such as bacteria, anything like that. And lastly, we basically want to get rid of any waste matter. And a big part of that is microplastics. Very small, little, man-made rubbish. We gotta get rid of that. Right, next slide. 3.
Alternative solutions. Some alternative solutions could be useful in this case due to the many limitations of desalination plants. One of these alternative solutions is capacitive deionization, or CDI. This process uses electrical fields in order to separate the salt ions out of the water. But does this by manipulating the different electrical charges found within salt ions and the charges found within water. This is limited in the fact that it can only be used in solutions containing low amounts of salt, and so it cannot be used in the general ocean. And it's limited in locations it can be used, and so it can really only be used in areas where a freshwater river hits the ocean, such as when the Mississippi River hits the Gulf of Mexico. Another alternative solution is temperature swing solvent extraction. It does this by introducing another solvent, such as calcium, into the liquid, which lowers the boiling point of salt water. And while this is good for energy efficiency, it is not good for expenses and waste. Another alternative solution is stepping up our current conservation and efficiency measures that are already in place. This does not harm the ocean and could be relatively inexpensive to do, and studies show that it could reduce water use up to 57%. However, there are still problems with this, like actually enforcing these measures and how it can be difficult to get them implemented in the first place with so many companies and private institutes relying on our current ways of treating water.
My name is Anna Zimmerman, and I'm going to be talking about some of the pros and cons of desalination plants. First, the method has been proven to be effective. Reverse osmosis is the method for removing the salt from the seawater, and it's a method that we've been studying for a long time, so we've proven it to be effective. The method is highly understood. Reverse osmosis is a highly understood method of purifying water, and it's been backed up by scientific evidence to prove that it's an efficient method of creating clean drinking water. There is a massive amount of ocean water as a source. Seawater would provide an almost inexhaustible source of water, even if we use all water from the ocean as our source. Even in times of drought, we would still be able to create fresh drinking water for people.
3.
Next, the plants are safely located. We would keep the plants away from large residential areas and put them in industrialized zones to keep away from residential areas so it doesn't pose a risk to people. It could preserve our current freshwater supplies. We're currently running out of fresh water, and our supplies is limited. This would help us preserve our fresh water and help us create more water that people can drink. Lastly, it's not dependent on changing factors. A huge problem with other proposed solutions is its increasing water demand weighs heavily on uncontrollable factors and other things that people cannot control and other solutions that we have.
3.
Next, we're going to talk about some of the cons of desalination plants. Firstly, its resulting brine can have a dramatic environmental effect. After we remove all of the salt from the seawater, we are left with this salt